Good morning, everyone. Today, we will discuss about the investment material. First, we will discuss about its definition. So, about investment material. So, first comes about the term investing. So, investing, it is defined as it is the process of covering or enveloping uh, an object such as the denture, tooth or wax form or crown, etc., with a suitable investment material before processing, soldering and casting. So investment, it is again defined as the ceramic material that is suitable for forming a mold into which the metal or alloy is cast. So the operation of forming a mold, the mold which is formed here, it is called as investing. Next comes about the properties of the investment. So the properties of the investment materials are it should be easily manipulated, then it has sufficient strength at the room temperature, and its stability, it should be stable at their higher temperature, and it should have sufficient expansion. Then it should be beneficial for the casting temperature. Then it should be porous enough to permit the air or other gases into the mold cavity to, and it should be escape easily. Then the next property of the investment material is it should be inexpensive. Next comes about its composition. So the investment material, it is made up of refractory material, binders, and other chemicals. So first comes about the refractory materials. Refractory materials, these are the materials that remains stable at their higher temperature. So its example is silica, and its function of the refractory material are it acts as a material that can withstand at high temperature, and it regulates the thermal expansion. Next composition is the binder. So binder, these are the materials that binds together the particles of the refractory substance. Example, gypsum, phosphate, and silica. So some binders for the gold alloy. So for the gold alloy, the binders are dental stone, and the investment for casting cobalt chromium alloy are the ethyl silicate, aluminum sulfate, and sodium phosphate. Next comes about the other chemicals. So in other chemicals, along with the refractory material and binder materials, there are other chemicals which can be used in the investment material. These chemicals are the sodium chloride, potassium sulfate, graphite, copper powder, magnesium oxide, which can be used in an small quantities. So we are going to discuss about the three types of the investment material. First is the gypsum bonded investment material. Second comes about the phosphate bonded investment material. And third comes about the silica bonded investment material. So first we are going to discuss about the gypsum bonded investment material. So the gypsum bonded investment material, these are the investment material which are the oldest materials and are used for casting the gold alloy. So, and the next one, the phosphate bonded investment material, they are used for the base metal alloys, and it is used in the fixed partial prosthesis. The third one, that is silica bonded investment material, they are used for casting of the base metal alloy particles, and it is used in the dentures. So first we are going to discuss about the gypsum bonded investment material. Gypsum bonded investment material, as already discussed about it, gypsum bonded material, they are used in investment during the casting of the gold alloy, and they can withstand the temperature up to the 700 degree. So according to the ADA specification number 2, there are of the three types of the gypsum bonded investment material. The type 1 is the thermal expansion type. The type 1 thermal expansion type, it is used for casting the inlays and crown. The second one, that is type 2. The second one is hygroscopic expansion material. It is used for casting the inlays and crown. And the third one is for casting of the complete and partial denture. These are the three types of the gypsum bonded investment material. Next, these materials are supplied as the powder, which are mixed with the water and are composed of the mixture of the silica and calcium sulfate hemihydrate. Then other minor components including are the graphite and the powdered copper. Then the composition of the gypsum bonded investment material, as already discussed, it is composed of the refractory, binders, and other chemicals. So here so in gypsum bonded investment material, the binder which we are using, that is alpha calcium sulfate hemihydrate. This provides the strength to the gypsum bonded material, and it is used 25 to 35%. Next comes as the refractory, that is we are using the silica. The silica in the form of the quartz and crystallite we are using in gypsum bonded investment material, and it is composed of 65 to 75%. Then the third one comes about the chemical modifiers. So the main function of the chemical modifier, it prevent the shrinkage, and the chemical modifiers which we are using in gypsum bonded investment material, that is 2 to 3%. So here it is the composition of the gypsum bonded investment material. Next, we are going to discuss about it in individual form. So the first one is alpha calcium sulfate hemihydrate. As already discussed, it acts as a binder. So the main function of the binder is it binds and holds the silica particles together. And its main function is it permits the pouring of the mix into the mold. Then it provides a strength to the mold, and it contributes a mold expansion. Then the next composition of the gypsum bonded investment material, that is silica. Silica, it acts as the refractory in the gypsum bonded investment material. So the form of the silica, quartz or crystallite which we are using in the gypsum bonded investment material, that is 65 to 75%. So the main function of the refractory material in gypsum bonded investment material, it acts as the refractory during the heating. Then next, it regulates the thermal expansion. Then the third one, it increases the setting expansion of the stone. Then the fourth function, silica in the investment, it eliminates contraction of the gypsum and changes it to the expansion during the heating. Then the third composition of the gypsum bonded investment material is their chemical modifiers. So the function of the chemical modifiers is they regulate the setting expansion and setting time, and also prevent the shrinkage of the gypsum when it is heated above the 300-degree centigrade. So the chemical modifiers which we are using in the gypsum bonded investment material, they are the boric acid and the sodium chloride. Next comes about the setting time of the gypsum bonded investment material. So the setting time of the gypsum bonded investment material, it should not be shorter than the 5 minutes, and it should not longer than the 25 minutes. Then usually the modern inlay investment material, it initially set between the 9 to 18 minutes. Then there are certain factors which determine the setting expansion of the gypsum bonded material. So the first one is about the greater the gypsum content of the investment, then greater the exothermic heat that is transmitted to the wax pattern, and greater their mold expansion. Then next properties is their lower the water powder ratio of the investment, then greater the exothermic heat, and the greater will be their setting expansion. Then the another property of the gypsum bonded investment material is thinner the walls of the wax pattern, greater the setting expansion of the investment. Then the fourth property of the gypsum bonded investment material is softer the wax, greater will be their setting expansion, which we are using in gypsum bonded material. Then there are certain properties which determines the gypsum investment. The first one is their thermal behavior. Second comes about their expansion. Third comes about their strength. Fourth comes about their porosity. Fifth comes about their fineness. And the sixth one is their storage. So the first about their thermal behavior. In thermal behavior, we are going to discuss about their two types of behavior. The thermal behavior of the gypsum, and next comes about the thermal behavior of the silica. Then in expansion, we are going to discuss about its three types. So first one is normal setting expansion. Second comes about their hygroscopic setting expansion, and the third one is about their thermal expansion. Then next comes about their strength, then porosity, then their fineness, and the sixth one is about their storage. So the first one is about their thermal behavior. So as already discussed, the thermal behavior of gypsum and the thermal behavior of the silica. So in thermal behavior of the gypsum, when gypsum is heated at the high temperature, it shrinks and it get fractures. So at 700 degree, it shows the slight expansion, then the greater amount of the contraction. Then the shrinkage is due to the decomposition and the release of the sulfur dioxide, and it contaminates casting with sulfide of the silver and copper. So gypsum bonded investment material should not be heated above the 700 degrees Celsius. So here it explains this, gypsum heated at high temperature and it shrink and it fractures. Then next in thermal behavior, next we are going to discuss about the thermal behavior of the silica. So in silica, as already discussed, we are taking quartz and crystallite form of the silica. So when the quartz and crystallite form of the silica is heated, it changes its crystalline form, and it occurs at the transition temperature characteristics of the particular form of the silica. So in case of the quartz, when it is heated, inverts from a low form known as the alpha quartz to its high form, and it is known as the beta quartz when it reaches the temperature of 375 degrees centigrades. Next, in the form of the crystallite, when it heated, it inverts from its low form or alpha crystallite at the temperature, and it ranges between the 200 to 270 degrees Celsius. Then the next property is about their expansion. So it is for casting shrinkage of the gold alloy. Then here in expansion, we are going to discuss about the three types of the expansion. First comes about their normal setting expansion. Second comes about their hygroscopic setting expansion, and the third comes about their thermal expansion. So the first is about their normal setting expansion. In normal setting expansion, there is the mixture of the silica and dental stone we are using, and the result in the setting expansion which is greater than when gypsum product is used alone. So when the silica particles probably interfere with the intermeshing of the crystals as they form. So as we know that the ADS specification number of the gypsum bonded investment material is 2. So in type 1 investment, it permits maximum setting expansion in an air is 0.05%. Then in the modern investment, it shows the setting expansion of 0.4%, and it regulates to retardants and the accelerators. So in normal setting expansion, it ranges between the 0.05% to 0.4%. Then next comes about their hygroscopic setting expansion. So hygroscopic setting expansion, it occurs when expansion that occurs as the investment harden when it is immersed into the water. So hygroscopic setting expansion, it occurs when the gypsum bonded investment material when it is dipped into the water. So this is one of the method for expanding the casting mold to the compensate for the casting shrinkage. So the hygroscopic setting expansion may be 6 or more types greater than the normal setting expansion. Next comes when the water is drawn between the refractory particles by the capillary action, and thus it causes the particles to separate and creating an expansion. So the investment should be immersed in water before the initial set is complete. And again, according to the ADS specification number 2, the type 2 investment type 2 investment. So the type 2, that is hygroscopic setting expansion, it ranges between 1.2 to 2.2%. In normal setting expansion, it ranges between the 0.05% to 4%, whereas in hygroscopic setting expansion, it ranges between 1.2 to 2.2%. Again, there are certain factors which determine the hygroscopic setting expansion, which we are going to discuss about it. So the first one is effect on their composition. Next one, there are effect on the water powder ratio. Then next comes about the temperature. So the first one, the hygroscopic setting expansion, how they affect on their composition. So here it shows that the finer the particle size, greater will be their hygroscopic setting expansion. So the finer the particle size of the silica, the greater is their hygroscopic expansion. Then higher the silica content, greater will be their expansion. Next, another factors which determine the hygroscopic setting expansion, that is effect on their water powder ratio. So the higher the water powder ratio of the original investment water mixture, lesser is the hygroscopic their setting expansion. Then the next one is effect of their temperature. So effect of their temperature, higher the temperature of immersion water, less is the surface tension, hence greater will be their expansion. Then the next factors which affects the hygroscopic setting expansion is effect of their time. So the effect of time, immersion before the initial set causes greater their expansion. Then the effect on the spatulation, the shorter the mixing time, less is their hygroscopic setting expansion. So these were the certain properties that determine the factor. These are the certain factors which determine the hygroscopic setting expansion. Then there is the critical point, the term critical point here it determines the maximum expansion is called as the critical point. So this critical point can be raised or lowered easily by changing their manipulation condition like water powder ratio, time of the spatulation and age of the investment material. Then next property is the particle size of the silica. So finer the particle of the silica, it produces greater hygroscopic expansion. The hemihydrate particles have little effect on this expansion. Then next comes about their thermal expansion. So in expansion, they were of three types. Normal setting expansion, it ranges 0.05 to 4%. Then next we discuss about the hygroscopic setting expansion. It ranges 1.2 to 2.5%. And the third, we are going to discuss about the thermal expansion. So the thermal expansion is directly related to the amount and type of the silica employed and the contraction of the gypsum. Here the contraction of the gypsum is entirely balanced when the quartz content is 75%. So the in expansion, the normal setting expansion was 0.05 to 4%. And then next comes hygroscopic setting expansion. It where ranges from 1.2 to 2.2%. Then next thermal expansion, it ranges between 1 to 1.6 percentage. So the maximum thermal expansion we attained at the temperature not greater than 700 degrees Celsius. So gold alloy are adapt to contaminated above this temperature. Then there are again certain factors which determine the thermal expansion. There were certain factors, we discuss about certain factors that determine the hygroscopic setting expansion. Similarly, there are certain factors which determine the effects of the thermal expansion. So here first one is about the water powder ratio. Here in water powder ratio, more the water used for the mixing, less will be their thermal expansion. Then the another factors which affect the thermal expansion is effect of their chemical modifier. So the addition of a small amount of the chloride of the sodium, potassium and lithium of the investment, it affect their thermal expansion. Then next property, as we discussed, there are certain properties of the gypsum bonded investment. So we discuss about their thermal behavior. Next we discuss about expansion. Third we will discuss about their strength. So the how the strength affect the gypsum bonded investment material. So as we already know, the ADS specification number of the gypsum bonded investment material, that is 2. So it requires a minimum compressive strength of 2.5 MPa 2 hours after the setting of the investment. Then the next property. So next comes about their porosity. Then we will discuss about their fineness. Then we will discuss about their storage. So in porosity, more gypsum crystals are present in the set of investment, then less is the property. Here it shows that more gypsum crystals present in the investment, less will be their porous. So less the hemihydrate content, greater the amount of the purging water, more will be their porous. Then the next property is about their storage. So it should be stored in the airtight and moisture proof container, and it should be purchased in small quantities. So here we complete about the gypsum bonded investment material. Here it shows that the gypsum bonded investment material, it is made up of the refractory material and binder, and there we discuss about the individual their properties. Then next comes about the phosphate bonded investment material. So in phosphate bonded investment material, the AD specification number of the phosphate bonded investment material, that is 126, and the old it was 42. Then the phosphate bonded investment material, it is used for investment. It is widely used in dentistry and it is used for casting of the palladium based alloy. Then the phosphate bonded investment material, it is used for casting of the cobalt chromium alloy and it can withstand at high temperature, that is 850 degree to 1504 degrees Celsius. So here the metals which have high melting point are mainly cast by this investment material since it is more stable at their high temperature. Then the types of the phosphate bonded investment material. So according to the ADA specification number 92 or ISO number 9694 phosphate investment material are classified into two types based on their application. So in type 1, it is used for inlays, crown and other fixed restoration, and type 2, which is used for the partial denture and other cast removable restoration. Next comes about their composition. So in composition, again, it is made up of refractory material, that is, we are using silica, then binders, modifiers, and liquid. So here binder, two types of the binder we are using, phosphate ion and magnesium oxide ion. And next comes about their modifiers. Modifiers which we are using in phosphate bonded investment material, that is carbon. And the liquid which we are using in phosphate bonded investment material, that is water or colloidal silica. So first comes about the refractory material, silica in the form of the cristobalite or quartz or the mixture of these two in the form of it forms approximately 80%. Then next comes about the binders. Here binders, it has two components, that is the phosphate ion in the form of the acidic form and magnesium oxide in the form of the basic form. So originally phosphoric acid was used, but at the present mono ammonium phosphate is used. So this undergoes acid base reaction. Here acid base reaction occurs between the acidic form of the phosphate ion and the magnesium oxide, that is the basic form. That's why it forms the acid base reaction between the acidic form of the mono ammonium phosphate and the basic magnesium oxide. Then next comes about the modifiers. So modifiers are added to regulate the setting time and in aid to expansion of the investment. Then the here the carbon which we are using as the modifiers in phosphate bonded investment material. Then next comes about their liquid. So the liquid which we are using in phosphate bonded investment material, that is, it consists of either water or colloidal silica, that is silica solution. So colloidal silica, it has two purpose. First purpose of using the colloidal silica as in the form of the liquid in phosphate bonded investment material is it provides strength of the investment. Then next, it contributes to the hygroscopic expansion. So when only water is used, there is very negligible hygroscopic expansion. So the setting reaction of the phosphate bonded investment is when the ammonium phosphate and magnesium oxide react with the water, it forms the magnesium ammonium phosphate and water. So this reaction takes place at the room temperature and it is in exothermic in nature. So here in this reaction, again, when the ammonium phosphate, it and magnesium oxide, it react with the water, there is formation of the magnesium, ammonium phosphate and water. Next comes about their setting time. So the setting time of the as we already discussed, the setting time of the gypsum bonded investment material, it ranges between 5 to 25%. There is the setting time of the phosphate bonded investment material. It is the setting time, then the working time of the phosphate bonded investment material is relatively lower, lesser than gypsum bonded. So here the temperature affects the setting time adversely. Warmer the mix, faster will be its setting time. And there the longer spatulation time, it accelerates the reaction. Then addition of water to the silica, it increases its working time. So here we discuss there are the certain factors which usually affects their setting time. So the first one is temperature. Here the temperature, it shows the warmer the mix, faster will be their setting time. Then next property is longer the spatulation time, it accelerates, it increases the reaction. Then the third is addition of water to the silica. Addition of water to the silica and phosphate bonded investment material, it increases its working time. Then Again, in thermal expansion, so thermal expansion is also great for colloidal silica mixed material. The combined setting in thermal expansion for phosphate investment is around 2%, and if the special silica liquid is used. So we discussed about the phosphate bonded investment material. Earlier we discussed about the gypsum bonded investment material. Next comes about the ethyl silicate bonded investment material. So ethyl silicate investment material, its ADS specification number is 126 and its old specification number is 91. So for ethyl silicate bonded investment material, it is also known as silicate bonded investment or silica bonded investment material. Then it is used for the nickel based alloy. It is used in investment. It is available in powder and liquid form. Then again, its composition, that is refractory material which are using here. The refractory material which we are using here, that is in the form of the silica. And the next one is binder. The binder, that is silica gel. It is used in two form, sodium silicate and colloidal silica. So again, the refractory material which we are using here, that is powdered quartz or cristobalite. It acts as the refractory material. Then next about their binders. So binders, again, it bind the refractory material. So here the binder which we are using here, that is silica gel in the form of sodium silicate and the colloidal silica. Then next comes about the setting reaction. So the setting reaction of the ethyl silicate based reaction, that is occur in the three stages. First one is their hydrolysis form. Second comes about their gelation process, and third one is about their drying process. So the first stage is hydrolysis. The first stage of the setting reaction is called as hydrolysis. So in hydrolysis form, it is usually supplied in the two bottle system. In first bottle, it contains the ethyl silicate solution, and the second bottle, it contains hydrochloric acid. So in second reaction, in second bottle, when the hydrochloric acid is used, it react with the ethyl alcohol, and it used to improve the miscibility of both the component. So the setting reaction is when the ethyl silicate react with the water in the presence of hydrochloric acid and the ethyl alcohol, it will form silicic acid. Again, I am explaining, when the ethyl silicate reacts with the water in the presence of hydrochloric acid or ethyl alcohol, it will form silicic acid. Then the next stage comes about their gelation. So the setting reaction, there were three stages. First one is about hydrolysis, second one is about their gelation, and third one is about their drying. So in hydrolysis, as already discussed, it occurs in two bottle system. First bottle, it contains ethyl silicate solution, and second one is HCl. Then the next stage comes about their gelation. So in gelation process, solution is mixed with the quartz or cristobalite, to which are added a small amount of the finely powdered of magnesium oxide to render the mixture of the alkaline. So the solution plus cristobalite or quartz plus magnesium oxide or ammonium chloride, it will form the polycyclic acid. Then the third stage is called as drying. So in drying, when the soft gel is dry at temperature less than 168 degrees Celsius, it will form the hard gel of the silica and alcohol group and water. So the soft gel is dry at the temperature below 168 degree centigrade. So during the drying, the gel form, it loses its alcohol and water, and it will form the hard concentrated gel of the silica particles that is tightly packed together. So there is comes a term, that is green shrinkage. So the considerable volumetric contraction, it occurs the drying when it reduces the size of the mold. So this contraction is known as the green shrinkage, and it occurs in addition to the setting reaction. So here our investment material is over. So in investment material, we discussed about their three types. First one is gypsum bonded, second were the phosphate bonded, and the third one is silica bonded. So in gypsum bonded, they were used for the gypsum bonded investment. It is used for casting of the gold alloy, and it can withstand a temperature of 700 degrees centigrade. Whereas in phosphate bonded investment material, it is used for casting of the cobalt chromium alloy, and it can withstand at high temperature, that is 850 to 1504 degrees centigrade. Whereas in ethyl silicate bonded investment material, it is used it is again it is used for investment of the silica, and its ADS specification number is 126.